Hello, welcome to History of Creativity, and today we'll continue with our discussion of the Greeks, one of the most important civilizations of the ancient world. Today we'll talk about Greek democracy and science. Let's begin with the Dark Period. After the heroes had returned to Greece following the Trojan War, their lives were in terrible turmoil. Almost every one of these heroes had problems, and those are stories that are told in Greek drama as well as some literature. But it didn't take too long until there was an invasion of Greece from the north. This is an invasion by a group called the Dorians. They did not leave written records, and so we call this period the Dark Period of Greece. We really don't know much about it. We know that these Dorians defeated this Mycenaean civilization of the heroes, and we also know that they retained the polis structure, that is the city-state structure of Greece. Each of these cities, like Sparta, Athens, Corinth, and so on, were independent, powerful city-states, and that political structure was retained. That's good and bad. The bad, the curse of these city-states, is that local pride developed into bitter jealousy between the states, and therefore there was almost constant war between these city-states. But there was a benefit, and that is that government was kept at a local level, and that encouraged experimentation and individual growth in cities as they attempted to find the best solution for their particular city. Let's take a look at two or three of these cities and we can understand some of the details. First, one of the most important and certainly the most powerful militarily of these cities was Sparta. Sparta is down on the southern peninsula of the Greek mainland. It's an area that is called the Peloponnesian Peninsula. And Sparta focused almost entirely on military affairs. So much so that young boys, as early as the age 7, were taken into a school where they learned military tactics, military behavior, military concepts. And they stayed in that military obligation until they were 60 years old. Obviously, there was very little else for the Spartans to do. They didn't have to worry about feeding themselves because they had dominated territories around them, and those dominated territories were responsible for providing food and other necessities of life, taking care of the city and so on. So the Spartans could focus 100% on just the military side of their existence. Women focused on bearing sons who would be available for this military obligation. The Spartans had almost no time for art, no inclination for art. And the militaristic culture that the Spartans had lasted all the way through what we call the classical period, that is down to about 350 BC. There are some, what I would say, horror stories about what the Spartans did to toughen their young men. For instance, they had a mixture of vinegar and blood and other things that they used as a soup. It sounds ghastly to me, and yet somehow the Spartans survived this terrible, difficult treatment and became widely recognized throughout the Greek world as the most important military city. One of the concepts that the Spartans used very effectively is called the phalanx. Here we can see a picture of soldiers arranged in a phalanx formation, very tightly packed, many soldiers across each side, probably about 20, and about 20 rows of soldiers deep. So we have a breadth and a width, a depth of soldiers, each heavily armored and each carrying a very long spear. And the first 3 or 4 rows of these soldiers would lower their spears and they would move forward almost like a tank going into some infantry unit. And they would impale the other unit on their spears, and then when they got into close contact, these close ranked soldiers would put their shields together, and they may draw a short sword at that point and fight hand-to-hand combat, but always behind a shield. And this formation is especially good for Spartans because they understood that unity made the phalanx work, all soldiers doing their duty. And that was exactly the training that the Spartans gave to their people.
Your father should have told you how a phalanx works. We fight as a single, impenetrable unit. That is the source of our strength. Each Spartan protects the man to his left, thigh to neck, with his shield. A single weak spot, and the phalanx shatters. Thigh to neck, Ephialtes.
Spartans! Lay down your weapons! Persians! Come and get them! Give them nothing, but take from them everything! Steady! That's the best you can do!
Now let's go to the other end. Talk about a completely different city, Athens. Athens was not based on military success. It was based on trade and culture. Those two go together because as the Athenians traded throughout the Eastern Mediterranean and the Black Sea, they would find cultural aspects in all of these other places, and they would bring them back to Athens where they would enjoy the cultural benefits of the exploration into these other territories. In addition to trade and culture, the Athens focused on individualism rather than this collective effort that the Spartans had focused on. The Athenians strongly supported the arts and sciences, so there was tremendous cultural progress in Athens, where Sparta, we would say today, was a backwater place that had very little culture. The Athenians are perhaps best known for their experiments in government, and we will focus now on some of those experiments. Interestingly enough, the experiments in government, the arts, the sciences, all of that was brought to them by a very powerful navy. This navy was used obviously for trade, but they also developed a strong, powerful, warlike navy. And so the combination of the Spartans on the land and the Athenians on the sea was helpful when the Greek mainland was invaded many years later by the Persians. Let's now begin our discussion of Athenian political power with the concept of democracy. How did it start? Where were its roots? The first is Draco. He was a ruler of Athens, and he believed in the rule of law, perhaps the most fundamental concept of democracy. The laws were not easy, and his were harsh and were posted for all to see. In fact, today, when we have harsh laws, we call those laws draconian in his honor, or in his, I suppose, remembrance, if not honor. By exhibiting these laws in a public posted place, it allowed everyone to see them, and it gave expectation that everyone would obey them. And Draco insisted that that be the case. All classes of people, politicians, bureaucrats, soldiers, tradesmen, were all subjected to the same set of laws. And therefore, perhaps most important of all, the contribution of Draco is not only the rule of law, but the even-handed application of that law. Next, let's talk about the method of establishing laws within this system that grew up in Athens. They developed a group of people who would get together. They were the landholders. Now, some have criticized Athens because they said only a few people in Athens are the ones that had all of the power. Well, while that might be true, think of it the other way. Athens at least shared power between a group of people rather than a single ruler who had all of the power. So let's look on the positive side and say, here are a group of people, mostly landholders, who gather together and they vote jointly to create the laws. This group, what today we would call a parliament or a congress, was called the Areopagus, and it's characteristic of a rule by a group. And that kind of rule we call an oligarchy. So the very first beginnings of democracy were a rule by a group or an oligarchy in the city of Athens. Soon, there was a man who came into power in Athens. He was elected as one of the local leaders, and his name was Solon. Again, we use his name to designate, even today, those in Congress who enact our laws. They are called Solons. Well, Solon really did give a broader participation in the government. It was no longer just the elite families who held land. He allowed merchants, very important economically to the city of Athens, and other non-landholders to participate. So here Solon has contributed, now for the first time, a system where people of all economic classes, or at least citizens of not landholding classes, but still probably wealthy enough to pay considerable taxes, but all of those people were involved in the government. Solon also gave us an institutionalized trial by jury, incredibly important in administering proper justice. And Solon gave a stable currency system, very, very important in a trade-based society, and also important in a society that was going to become ever more democratic, because people at all levels would then have money that they could spend, and they could use that to increase their status within the community. Finally, Solon gave a feeling of freedom of thought and freedom of action within the law. This wonderful concept really was the basis for our concept of democracy. Sadly, upon the death of Solon, there was a period of chaos within Athens. They couldn't find a good leader. And it's interesting again that we get a descendant word from this period. Greece gives us lots of phrases and words that are important in our modern life. The word for leader in Greece is anarchon. And the prefix for without is an. So if you have an anarchon, that is a period without a leader. And of course, anarchon has come to us as anarchy. And that certainly is what they had for about 2 generations following the death of Solon. But, heave a sigh of relief, along came a marvelous leader, the man who most people would look to as the greatest leader in the history of classical Athens. This man's name was Pericles. He brought the government together because he was a strong military leader and they trusted him. In addition to that, he was a great believer in the arts, and he was a great believer in democracy. So combining all of those things together, we get a tremendous power in Athens during the reign of Pericles. He gave great public works. Today, when you go to Athens, in the center of the city there is a hill with a flat top. And that hill is the place where Pericles built many of the beautiful temples and other public works. That hill is called the Acropolis, meaning high city. It's the little high city on top of that hill. And we will, over the next few lectures, discuss some of the important buildings that can be found on that beautiful place. He also created theaters. Here we see a picture of one of the theaters that is Greek in style, and he put one of those on the side of that hill in the center of the city, as well as many temples built throughout Greece, but especially on the Acropolis in the center of Athens. I think we can find out some things about Pericles by what he said at the death, at the funeral of one of the famous soldiers of Athens. Actually, it was a remembrance of many soldiers, but they took the opportunity for a particular one. This is reported to us in the words of a famous historian whose name is Thucydides. Let's read now the words, supposedly, of Pericles as reported to us by this historian. Pericles says, "Our Constitution does not copy the laws of neighboring states. We are rather a pattern to others than imitators ourselves. Its administration favors the many instead of the few. This is why it is called a democracy. We celebrate games and sacrifices all the year round. While the magnitude of our city draws the produce of the world into our harbor, so that to the Athenians the fruits of other countries are as familiar a luxury as those of his own." As you see, he's very proud of the lifestyle as well as the governmental system. He helped organize an empire, and I hesitate when I say the word because he probably would have been offended if we were to call what he had organized as an empire. He called it the Delian League. Delian, named after one of the islands that he organized under Athenian control, that island named Delos. And here we see a map of the area controlled by Athens. It is the Delian League. He forced all of the cities and towns in this area to pay a tribute to the city of Athens. And then he used the money from that tribute money to build the beautiful buildings in the city of Athens. I think that brings in a question about creativity. What is the effect of having an empire on creativity? In this case, we probably would have to say that the empire improved creativity because it funded what we see as the beautiful buildings of Athens. In addition to the question about whether the empire has an effect on creativity, we could also ask this question: can a democracy maintain an empire? It's difficult to think of democracies that have major empires any time in history. And we have to think, well, maybe Greece was the exception. It was a democracy with an empire. But as we will see, that empire didn't last very long. Let's go to another city within Greece, the city of Corinth. Here we see a picture of one of the temples in the ruins of Corinth. It is the place where Paul taught. Of course, he also taught in Athens, but in Corinth, there are some places where it's pretty obvious that Paul would have taught. The reason this city, Corinth, is important is because it is at the place where the Peloponnesian Peninsula barely touches the peninsula of mainland Greece just to its north. There's a very narrow isthmus connecting these two bodies of land. That isthmus is so thin that ships anciently were just simply pulled across the isthmus on beaten down or rocky and later concrete paths. Today there is a canal that runs through that area, and here we see pictures of the canal being built and of ships actually going through the canal. The second picture is taken from the bridge that you can see in the background in the first picture. It's a beautiful sight, and it's kind of fun to go through the Corinthian Canal. Now let's talk about the end of the Athenian Empire. That end really began with what we call the Peloponnesian War. Because of Athens' power in the islands to the east of Greece in the Aegean Sea, there was a natural rivalry between Athens and Corinth. Corinth had its power to the west and Athens to the east, but the Athenians were not satisfied with just dominating the Aegean. They also wanted to go westward in the Mediterranean and dominate the Adriatic and perhaps even further. And therefore they encroached on Corinthian territory, made Corinth mad, and they wanted to retaliate. Because of the natural rivalry between Sparta and Athens, such completely different city-states, completely different societies, the Corinthians found a willing ally in Sparta, and war was begun. The war was fought almost entirely within the territory surrounding the city of Athens. There were times when the Athenians came under siege within their own city. There were times when the Athenians left the city and they vacated and went to other parts of Greece, and then they returned when the fighting season was over. Back in these days, you only fought during the good months of the year. This war went on for many, many years, but eventually, after the 20-year war period, Athens was defeated, and Athens was ruled by a group of Spartans. They were hard on the Athenians, and the Athenians resented these warlike, semi-barbaric, in the eyes of the Athenians, Spartans who ruled over them. And eventually, the Spartans were ejected from the city, and the Athenians regained control. But it costs too much. The war had taken the life out of the Athenians and had taken most of the life out of the Spartans and the Corinthians, leaving all of Greece subject to invasion. And shortly thereafter, within one generation, a man from the north named Philip, a Macedonian, invaded Greece and was able to conquer all of it. We'll talk more about Philip in light of a later lecture, because Philip and his son Alexander have done a tremendous service for spreading Greek culture throughout the world. But as Philip conquered all of Greece, we can call an end to the Golden Age. What is then the effect of war on creativity? Is it positive or negative? Well, the answer is both. In the case of war helping creativity, think of the advances in weaponry and systems and warlike implements. Think of how there is support for functions that develop much faster because of the exigencies of war. How production methods are improved because people need goods, and how economies boom. Sadly, during those booming economy periods of war, the arts are stripped of their money because all of it goes into the war effort. So to some extent, technical creativity is improved, but artistic creativity is often diminished during war. There are other problems with war and creativity. Leisure time is reduced, and we have heard and seen that leisure is required for creativity. You have to have some time to think and progress and move forward. In addition to that, there are some creative people that are simply killed in the war, and of course that cuts short any creative effort that they may have had. We've already mentioned the money is diverted away from the arts into military pursuits. And finally, there was a potential weakening of both sides, making them vulnerable to attack by someone who might not be very creative. And that was certainly the case of Philip and the Greek city-states, principally Athens, Sparta, and Corinth. Well, let's look back on democracy and warlike behavior. Which is remembered most, Athens or Sparta? When we think of Athenian institutions, we think of universities. And as we will see in later lectures, the concept of a university-like school was begun in Athens. We think of democracy. We think of freedom. We think of rule by law. Truly, Athens is strongly remembered. What do we think of when we think of Sparta? Well, perhaps a football team. Not what we would call the basis of civilization, although to some people, especially those at Michigan State, probably pretty important. Now let's talk about one of the most critical parts of ancient Greece, and we'll step backward in time now and retrace the concepts of science. Science in ancient Greece was an outgrowth, as we've seen in a previous lecture, from the Greek alphabet. That alphabet that had letters and vowels, all capable of expressing spoken language in the written word. Very, very important in the case of science because it allowed the language of the ancient Greeks to be non-ambiguous, to give details, and to give precision. Here we see a picture of the four elements of which everything was composed: air, water, earth, and fire, and the four characteristics associated with those elements: wet, cold, dry, and hot. And we'll talk more about those as we progress through this lecture and succeeding lectures. I'd like to first begin with a man who is considered by most to be the first scientist. Not that he's the first observer of the world, certainly not, but he was the first one to think of science in the way that we do today, that is, a problem-solving method that would give us understanding of the world. And he was a philosopher, and he studied the world, and we call those people natural philosophers, and certainly Thales fits into that category. He provided evidence for his conclusions, that is, he backed up what he thought with physical evidence, and that also was a characteristic of science. So when Thales said this, and I will read his words in translation, we can see that science really began. He said, "All events, even extraordinary ones, can be explained in natural terms that can be understood by humans. Therefore, the investigation of natural events, even those that are extraordinary, can be reduced to methods that humans can understand." He said, in essence, the world is logical. Now, I want you to notice that word for a moment. The word logical comes from the Greek word logos. And as we will see in many subsequent lectures, the word logos is very, very powerful. And one of the meanings of logos is logical. Other meanings will be explained in future lectures. Thales also gave us some marvelous concepts besides the theory of science. He learned how to steer ships by the stars. He determined the height of the pyramids by a shadow method that presupposes concepts that today we would call trigonometry. He was able to predict a lunar eclipse, marvelous concept in terms of observation of the heavenly movements, and he had an interesting concept. He believed that water was the fundamental element of all things. Now, remember what the four principal elements are. Water, the one that Thales chooses as the most fundamental, air, earth, and fire. Now, why would he say that water is fundamental? Well, first of all, he looked at rivers and could tell that they were evaporating, and he saw clouds come in and rain, and he saw many other things that seemed to have water in them. And before we laugh too strongly at Thales, let me tell you about an experiment that was conducted in the 16th century and has been repeated on several other occasions to prove that it was true. This experiment involves a potted tree. This tree and its pot will be weighed, and weighed with some precision. Then the tree is watered for a long period. In this particular case, it was watered for 5 years. After 5 years, obviously the tree had grown tremendously. The pot, we presume, had stayed the same. And the pot and the tree were reweighed. The result was that the tree-pot combination had gained 10 times its weight with just water being added. Now, the conclusion of that could be that water, therefore, was what made the tree large. And it could be concluded, therefore, that water was the critical element that made the tree what it is. Can you see that the ideas of Thales were really not that stupid? Now, let's talk about the most famous of all of the Greek scientists. His name was Pythagoras. He was simply the inventor of mathematics. He developed a system of showing mathematical equations. It's the familiar A equals B plus C. In addition to that equation for mathematics, he believed that small whole numbers were the fundamental. Now that may be shocking. It backs away from the four elements of Greek science, and it says those elements are manifestations of other things, and those other things that lie behind them are actually small whole numbers. Well, we laugh at that today, and we think that that couldn't have been so. But in truth, there's a lot of things today that are dependent on small whole numbers. I think of quantum chemistry. We have quantum numbers that are small whole numbers. And there are many, many places where small whole numbers and their ratios are important in modern life. Interestingly enough, Pythagoras also believed that numbers that, when divided one by the other, gave non-whole numbers. That is, numbers that could not be expressed by the simple division of whole numbers. He called those irrational. You think about the word irrational, it means non-logical. And in fact, he thought that they were literally evil. He gave us the Pythagorean theorem, which is, of course, fundamental in geometry. He also talked about an interesting arrangement of numbers and how they depict various shapes. For instance, there are square numbers, and when arranged, as we see here in the slide, 1, 4, 9, and 16 are square numbers, and in fact we see that 1 squared is 1, 2 squared is 2, 3 squared is 3, and 4 squared is 16. Therefore they are literally square numbers. And we also see triangular numbers, 1, 3, 6, and 10, because they form a triangle. These concepts lend support to the fact that shapes and therefore elemental materials might just be made of some things like small whole numbers, or at least characterized by them. Here's a little video that I think you'll enjoy that talks about Pythagoras as seen from the viewpoint of Donald Duck.
Come on, let's go to ancient Greece, to the time of Pythagoras, the master egghead of them all.
Pythagoras?
The father of mathematics and music.
Mathematics and music?
Ah, you'll find mathematics in the darndest places. Watch. First, we'll need a string. Stretch it good and tight, plunk it. Now divide in half. Plunk again. You see? It's the same tone, one octave higher. Now divide the next section. And the next. Pythagoras discovered the octave had a ratio of 2 to 1. With simple fractions, he got this. And from this harmony in numbers developed the musical scale of today.
By God, you do find mathematics in the darndest places.
You can imagine how excited Pythagoras was when he shared his findings with his pals, a fraternity of eggheads, known as the Pythagoreans. They used to meet in secret to discuss their mathematical discoveries. Only members were allowed to attend. They had a secret emblem, the pentagram. It was our old friend Pythagoras who discovered that the pentagram was full of mathemagic. The two shorter lines combined exactly equal the third. And this line shows the magic proportions of the famous golden section. The second and third lines exactly equal the fourth. Once again, we have the golden section. But this is only the beginning. Hidden within the pentagram is a secret for creating a golden rectangle, which the Greeks admired for its beautiful proportions and magic qualities. It's a most remarkable shape. It can mathematically reproduce itself indefinitely. All these rectangles have exactly the same proportions. This figure also contains a magic spiral that repeats the proportions of the golden section into infinity. To the Greeks, the golden rectangle represented a mathematical law of beauty. The Parthenon, perhaps one of the most famous of early Greek buildings, contains many golden rectangles. These same golden proportions are also found in their sculpture. In the centuries that followed, the golden rectangle dominated the idea of beauty in architecture throughout the Western world. The Cathedral of Notre Dame is an outstanding example. The Renaissance painters knew this secret well. Today, the golden rectangle is very much a part of our modern world. The star jasmine. The starfish. The magic proportions of the golden section are often found in the spirals of nature's design.
In addition to the concepts of small whole numbers, Pythagoras found a wonderful ratio. Today we call it the golden ratio, and sometimes it is abbreviated as phi. The golden ratio, it's a number approximately 1.618. It is that ratio that when you take a line segment A and a line segment B and add them together, the ratio of A to A plus B is equal to this 1.618. So that magical relationship has so many interesting characteristics. It gives us the basis of a pentagon, and within the pentagon you can inscribe another star, another pentagon, and within that another and another. And so stars and pentagons can be inscribed as shown in the drawing. In addition to that, we can look at our own bodies, and we can note that certain distances, the ratio of one knuckle distance to the next, or the ratio of head distances to part of a head distance, and so on, often have these numbers that reoccur. Why, even if you look at rectangles, and there are special rectangles, obviously, that have that number ratio, it is very pleasing to our eye, and we see that the facade of the Parthenon in ancient Greece and the facade of the United Nations building in New York today have approximately that ratio. That ratio is also a number that generates a spiral. That spiral can be things such as seashells have that shape, or flowers, the way the petals grow, ram's horns, or entire galaxies. In fact, it seems that this ratio is the way that nature controls scale and keeps it proportional. Now think about the beauty and wonder of that concept, that there is a ratio that means that a ram's horn, even though small, and a galaxy, even though huge, have the same general shape because they follow this wonderful ratio. Indeed, it is called the golden ratio, and for good reasons. Today we can see even the curvature of DNA, the most basic molecule of life, follows the ratio that we have been talking about. It is a marvelous discovery by Pythagoras and his followers. Now let's talk about some lesser known but rather interesting scientists. One is Anaximander. Anaximander believed that fire was the most fundamental element, and he talked at length about why that would be so. Heraclitus said that the fundamental is change. No fundamental thing, but a fundamental concept. And he is the one who said, no one can step into the same river twice. Meaning, of course, that once you step in, the water goes past. It's no longer the same river because it has changed. Another interesting and quite confusing person was Zeno. Zeno believed that any movement is impossible because you can divide all space in half. Now that may sound just utterly ridiculous to you, and let's talk about how he came to that conclusion. Let's say that there's a man who's about 100 yards away from a pot of gold, and he wants to get there. Zeno would say, well, before you go all the way to the pot of gold, you must go halfway. But before you go halfway, you must go half of that distance. And before you go half of that distance, you must go half of another. And before you go to that, you must go half of another. Of course, we can keep going and going and going until it is obvious that before you move at all, you must go halfway. Therefore, Zeno says there is no way to move at all, at least logically, because you must first go halfway before you can go any movement at all. This is called Zeno's dilemma, or the dilemma of Zeno, and it lasted for a long, long time. Well, people were moving during that period, and it shows a little disconnect between the concepts of philosophy and the concepts of reality. But eventually there was a man who came who gave us a solution to the concepts or to the dilemma posed by Zeno. That man was called Democritus, and he gave us the atomic theory. He said that if you keep dividing halfway, 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 until you get to something very, very, very small, you will eventually come to something that is non-divisible, cannot be divided. And he gave that the word a, remembering a means non, and tomos, meaning divided. So it's atomos, or today, of course, we call it an atom. So Democritus said that there is at the smallest part of all matter something that cannot be divided in half. And because of that, when you move to encompass the whole thing. As soon as you do that, you've solved the dilemma of Zeno. So let's be grateful for Democritus, who has allowed us to logically move. Well, many of these scientists have been looking for a fundamental. And we can ask ourselves, why does science look for a fundamental? What is important about a fundamental? It is, obviously, something that scientists want to have as a basis on which they can act and form models and predict future events. The fundamental is that thing that they can depend upon, perhaps even the thing that does not change, except in the case where change is the fundamental. But it is that thing that is predictable in science. I hope you've enjoyed the discussion of Greek democracy in science, two of the most important things brought to us by the ancient Greeks. We'll talk about other important Greek contributions in future lectures. Thank you.